Today we're going to be talking about the unit circle. The unit circle is a circle whose radius is 1 and is centered at the center of a Cartesian plane, which is the regular xy axis. We measure the angle off the positive x-axis, and the quadrants of the circle line up with the quadrants of the Cartesian plane. The unit circle is measured in degrees or radians, which we'll be writing in green. First thing we're going to do is look at the first quadrant. Its center is at 0, 0, its right side is at 1, 0, and its top is at 0, 1. The first point is 0 degrees or 0 radians. The next point is 90 degrees or pi over 2 radians. Now we're going to take a middle important key point that's at 45 degrees or pi over 4 radians. We can break it up into y and x values, and its hypotenuse is always going to be 1. So let's just take this triangle and go to the next page. We're going to try and solve for the final values of x and y. And we know that x equals y because it's a 45, 45, 90 triangle. So if we are going to solve for it, we're going to have to write out Pythagorean's theorem, which is a squared plus b squared equals c squared. 1 is going to equal c, y is going to equal b, and x is going to equal a. So a squared plus b squared equals 1 squared. We're just substituting in c. But remember that x equals y, so a equals b. So we could just say that a squared plus a squared equals 1 squared. So 2a squared equals 1, a squared equals 1 half, a equals the square root of 1 half, a equals the square root of 1 over the square root of 2, a equals 1 over the square root of 2 times root 2 over root 2, which is just 1, and you get root 2 over 2. Root 2 over 2 is the value of both legs of the triangle. So when we're filling it out on the unit circle, the coordinates are going to be root 2 over 2 and root 2 over 2. X and y are both the same. But we have two more valuable points, which are pi over 6 and 2 pi over 6. It's 30 degrees and 60 degrees. First, we'll break up the 30 degree one. We're going to solve for the third angle. It's going to be 60 degrees. The height is going to be 1 half because the rules of 30, 60, 90 triangles. And the medium length side is going to be 1 half times root 3. Solving for the next triangle of 60 degrees, we find the third angle, which is going to be 30. The hypotenuse is always 1 on the unit circle. The shortest side is 1 half because, again, this is a 30, 60, 90 triangle. And the medium side is root 3 times 1 half. Now, if you notice, those two triangles look very similar, and they're just inverses of each other. Well, one is root 3 over 2 by 1 half. The other is 1 half by root 3 over 2. One of the great parts about the unit circle is that it's radially symmetric. The only difference is that the angles change all the way around by increments of 30 degrees, 45 degrees, or pi over 6 and pi over 4. The other difference is that the sign of the coordinates in each quadrant changes as you go around. In the first quadrant, x is positive and so is y. In the second quadrant, x is negative and y is positive. In the third quadrant, x is negative and y is negative. And in the fourth quadrant, x is positive and y is negative. We use the unit circle to evaluate for trig functions on the certain key points, and it gets us easy exact numbers. If we break down the key points into theta, x, and y, we get that sine of theta equals y, cosine of theta equals x, and tangent of theta equals y over x. Let's take, for example, sine of pi over 4. We know that pi over 4 is in the first quadrant, so we're going to expand the first quadrant and draw out a couple angles until we find it. Pi over 4 is the central angle. Break it up into a triangle, and it's going to be root 2 over 2 and root 2 over 2. Sine of theta is going to equal y. So sine of pi over 4 is going to equal the y value, and that's root 2 over 2. To quickly go over what we talked about in this video, the unit circle is a circle whose radius is 1, we measure in degrees or radians, and is used to evaluate trig functions on certain key points. Thank you for watching. If you want to read more about the unit circle, click this link and go back to our site.